today's lesson, we're going to be talking about converting radians to degrees. And to get started, let's talk a little bit about radians. Radians are actually a unit of measure for angles that's based on the circumference of a circle divided by its radius. Now that's a mouthful right now, but let's back up a little bit and talk about where did degrees come from. So hopefully you know that there's 360 degrees in a circle, and that came about because the Mayans simply decided that they liked base 60, and that they were going to say there was 360 degrees in a circle, and they just stated that, and it stuck, and everyone knows that that's how many degrees, a made-up thing, there are in a circle. However, mathematicians set out to create another type of unit for angle measure, and that unit is radians. And radians are more precise because they come from a ratio based on the measurements given in a circle. So they aren't arbitrary like a degree is. A degree is 1/360th of a circle, but radians are a little bit different. So first of all, let's start by talking about, this isn't anything you need to write down, just something to pay attention to. Let's start by talking about what this actually says. It says a unit of measure for angles based on the circumference of a circle divided by its radius. So if you flip over, and I already have this written, I rewrite that same concept as radian measure is simply the length of an intercepted arc divided by the radius. And I want to walk through an example with numbers before I do it in general. So I'm just going to simply do that on a piece of scratch paper. So to abbreviate this with variables, I'm going to say that theta, we're going to use that variable to stand for angle measure in radians, is equal to the length of the intercepted arc, also known as arc length, and there's a variable for arc length, it's s. And it's divided by the radius, which we can abbreviate as r. So say you're given an example, like, say you have this circle with a radius of 5, and the angle has an arc length of 8. Then we can find the radian measure of this angle, theta, by simply plugging in these values. So the radian measure here is going to be 8/5 radians. And again, I mean, we could change that and have a different circle, and we could say that the radius is only 2 long, and that the arc length is quite large, and say that it's 10 units, and then the angle's right here, theta. So we can calculate the radian measure of that angle by simply taking the arc length 10 and dividing it by 2, which gives us 5 radians. So that's how that equation works. So now we're going to back up and not use real numbers and figure out something that's actually quite profound. So in your little circle here, put a center, and then go ahead and draw a radius. Notice I keep using that standard position, so I keep putting my initial side where the positive x-axis would be. And we're just going to label that r for radius, an unknown amount. And instead of our angle being an arbitrary size like these two examples, let's make our angle actually go all the way around. So in degrees, we would call that 360 degrees. But we don't know how big all the way around the circle is in radians. We just don't know yet. And now the arc length would then be all the way around the circle. So if you can see, I'm tracing all the way around, and that's our arc length, S. Now here's where it gets interesting, because all the way around the circle, we have a formula for that. That's called the circumference. So in this example, the arc length is actually equal to the circumference of the circle. So you have to trudge back your memories of geometry. The equation for circumference of a circle is 2 pi r. And we don't actually know r, so we're going to say circumference or arc length is equal to 2 pi r. So now we've got all of our pieces set up. Just for kicks, let's see what happens when we try to calculate the radian measure in this example. So we're going to say theta equals, and for starters, I'm going to go ahead and write that abbreviated version here so we can see theta equals S over R. So now we're going to actually plug things in to try to calculate something. So remember, we're trying to determine the radian measure in a circle where the arc length is actually the whole thing. So we're going to plug in 2 pi r for our S, and then our radius is simply r. And now something interesting happens. Hopefully your algebra skills are kicking in, and you can see that the radius actually cancels. And so we're left with theta equals 2 pi. Well, that's really interesting because 2 pi is a number. We can approximate it to be 6.28. So actually, in a circle, no matter what the radius is, the angle measure all the way around is 2 pi every single time. So basically, 2 pi is the radian equivalent to 360 degrees. And we can actually take that a step further and say that pi is equivalent to 180 degrees. And we can figure that out just by dividing by 2. So whenever I started out, I said we were going to determine something quite profound. Well, basically, we found the conversion ratio to go between degrees and radians. And that conversion ratio is that pi is equivalent to 180 degrees. So pi radians, 180 degrees. And we're going to use that in the next 2 tabs.